Hello, I'm Diary, a master's degree at the TM Lab, and I'm going to review the paper today. First, the bibliographic information of the paper. This paper was published in the journal TFSC in November 2024, and the keywords and highlights of the paper are as follows. The table of contents of the presentation is the same as the table of contents of the paper. First, the research background and necessary. As technological innovation accelerates, rapid identification of development trends and topics of new technologies has become an important strategic factor for companies, research institutes, and policymakers. Technology prediction is a systematic and structural analysis method that predicts the direction and market opportunities of future technological innovations, and graph embedding techniques have recently attracted attention in the field of technology prediction. Graph representation learning can be utilized to visualize and analyze relationships between technologies more effectively. Therefore, this study intends to propose a new methodology that overcomes the existing limitations and enables prediction on more sophisticated technology, and the core goal of the study is as follows. Next, it is related work. First, technology prediction is a method predicting future technologies and development directions by analyzing past data and is largely divided into qualitative and quantitative methods. Existing technology inspection methods have limitations in that they do not consider word order, so their semantic expression is limited, and they don't consider the technological relationship between documents and the evolutionary process between technologies. Therefore, this study proposes a new technology prediction method that considers temporal factors by combining link prediction and node-to-back graph embedding. Secondly, link prediction is a technique that predicts the possibility of a future connection between two nodes and a graph. And the basic concepts of link predictions are as follows. In technology prediction, link prediction is applied on technology relevance analysis, patent database technology prediction, collaboration network, and knowledge graph analysis. There are methods of link prediction algorithm types such as similarity-based, path-based, machine learning-based. In this study, link prediction is improved by a supervised learning method that combines time series analysis rather than the traditional unsupervised learning method to dynamically predict the change in the relationship between technologies. Graph embedding is a technique that transforms graph structures into low-dimensional vectors, enabling efficient analysis while preserving complex network information of graphs. In the case of patent data, graphic representation of relationships between keywords can easily analyze relationships between complex technologies. In addition, existing LDA and word-to-back based analysis methods were difficult to reflect structural changes in technology networks, as they could only analyze associations between words. On the other hand, node-to-back is a technique that uses random walk to search for nodes in a graph and combines them with the word-to-back skip-gram model to generate vector representations. The two-back can reflect both local and global structured information, allowing for a clearer analysis of hidden relationships between technologies. Existing technology prediction research has been mainly used for patent classification and similarity analysis, but this study focuses on clustering technology topics through graph embedding and visualizing relationships between technologies to increase prediction accuracy. Next is the research framework. In this study, it designs an analysis framework for future technology prediction using patent data, and the core goal of this study is to combine linked prediction and node-back graph embedding to analyze changes in the technology network and drive future technology topics based on them. This enables dynamic technology prediction that reflects not just keyword frequency analysis, but also relationships between technologies and evolutionary process. I will explain the research framework in detail step by step. First, after collecting patent data using DII Patent DB, preprocessing is performed by refining text, converting lowercase letters, recognizing, removing non-verbal terms, extracting words and title words. After that, TF-IDF, TF-IDF is used to extract keywords of high importance from each patent document. Next, the process of building the keyword network by analyzing the relationship between keywords in the patent document for each time window is as follows. Through this process, it tracks the changes in the technology network over time and lays for the foundation for predicting the future technology structure. It is assumed that technology develops through recombination of existing technologies and that the formation of new connections between keywords implies the possibility of the emergence of new technologies. Therefore, the core goal of the research is to predict whether rather than connections between specific keywords in the past patent keyword network will be formed in the future. Through link prediction, it analyzes the relationship change between keywords and evaluates the possibility of connecting future technologies. The figure 2 is a visual representation of the how the structure of technology network changes as the time window changes. And initially, there are fewer edges between nodes, but the network expands as more and more connections are formed over time. In addition, Figure 3 shows the training process of the machine learning model for link prediction. After performing link prediction using various machine learning models, it compares the characteristics of each model and then compares the performance of each machine learning model with several metrics. The figure 4 describes the random walk method used by the node-to-back algorithm, and the concept of the node-back algorithm is as follows. Node-to-back is an embedding technique that transforms node-to-node relationships into vectors in graph data. Just as word-to-back transforms words into vectors in the word-to-back model, node-to-back transforms nodes for, from graphs into vectors and learns node-to-node relationships using the random walk-based search method. The random walk is an exploration method that starts from a specific node in a graph and selects the next node probabilistically, and this process is repeated to learn the graph structure. By learning the node sequence generated by the random walk with the skipgram model, vector embedding is generated. Then, embedding running is performed through the skipgram model, and vector embedding reflecting the structure information of the graph is generated through the corresponding process. Next, the optimal number of the clusters, Sk, is determined using select coefficient, and the final technical topic is identified and analyzed by performing technology topic clustering using k-means based on the set k value. In this study, blockchain technology is selected as a case study target to analyze future technology trends and conduct an empirical study to predict technology topics. This is because blockchain technology is rapidly de- developing in recent years as the distributed ledger technology based on decentralization, security, and cryptographic based characteristic. Predicting the future development direction of blockchain technology is important for understanding technological innovation and industrial development, seeking new opportunities, and establishing strategies to respond to future markets. In this study, DII was used as a data source to collect patent data related to blockchain and additional data for comparative analysis with the importance of blockchain technology. Through this, it confirms that blockchain is a technology that has recently grown rapidly and is a suitable case for technology prediction research. Next, keyword extraction and network analysis are performed using patent, title, and abstract as the basic corpus. First, the data was composed of time window every 3 years by reflecting the time flow of the patent data. As a result of performance comparison between machine learning models, the random forest model showed the highest accuracy and was selected as the final prediction model. After that, the, the ROC curve was used to visually express the classification performance of the model, which means that the closer the AUC value is to 1, the better the classification performance of the model. It shows that random forest model is optimized for machine learning based rank prediction based on the highest accuracy. This study created a network graph reflecting the predict new connections, including the top 100 nodes with the newest connections, and formed new links between keywords that were not previously connected. These suggest the possibility of new technologies or convergence between existing technologies. The silhouette coefficient is an index that evaluates how well clustering has been separated, and the highest silhouette coefficient is shown as table 6. Therefore, the feature terms of blockchain technology are set to 6 and the analysis is conducted. And because of applying k-means clustering, 6 feature key themes of blockchain technology are derived. Each cluster reflects the direction of development blockchain technology and represents the future core technology topics. Figure 9 is a visual representation of the two-dimensional reduced clustering result using the TSNE algorithm. Each node represents a keyword related to blockchain, and the points of the same color belong to same technology cluster. Through this, clustering was performed effectively, and each technology topic is clearly separated. Figure 10 is a graph that shows the relationship between technology topics by considering each technology topic as one supernode, and the thickness of edge is thicker as the correlation between the topic is stronger. As a result of the core analysis, the topic of blockchain network and security has the most connections. This means that the core blockchain technology is network security and data communications. As a result, the future core blockchain technology is network security, data protection, and transaction security, suggesting that real-time performance analysis and encryption technology play a supplementary role. The verification method consists of two methods, qualitative and quantitative, and this verifies that the methodology of this study enables precise and differenti- differentiated prediction of technological topics. This study proposed a new analysis methodology combining liquid prediction and notebook graph embedding to perform patent data-driven technology prediction. The core goal of the study was to overcome the limitations of the existing technology prediction methodology and to analyze the relationship between technologies more precisely in consideration of temporal changes. And the main contributions of the study are as follows. In addition, this study has several limitations, such as the limitations of data, the possibility of improving liquidation models, and the lack of long-term analysis of technology evolution pa- patterns, suggesting that future research is needed. That's it. That's it for the paper review. Thank you.